Okay, after we know the types of the crystalline solid, okay, what we learned from the beginning, we learned the solid, then types of the solid, crystalline solid, amorphous solid, and what are the different properties of the crystalline solid and amorphous solid. And we learned the types of the crystalline solid, right? What are the types of the crystalline solid? We learned ionic, covalent, molecular, and metallic crystals, and we know what are the different properties of them. Okay, now let me discuss about the important terms in our crystalline solids, that is crystal lattice and unit cell. Okay, so keep silent here. So this term crystal lattice and its unit cell. Okay, so these terms very important to understand. What the importance of this crystal lattice and unit cell? Now here, in order to construct the crystalline solid, or how the crystalline solids are constructed, so these two important terms we must understand very clearly. So in order to understand the crystal lattice, okay, crystal lattice also sometimes we call space lattice. So what do you mean by space lattice or crystal lattice? So I draw the very simple, three-dimensional space. This is the three-dimensional space. Here we have the three coordinates. Here is the z coordinate. So this one is the x coordinate. This is the one y coordinate, right? So this is the three-dimensional space. For every things when we construct, we require this space. That three-dimensional space where the constituents can be arranged in our crystal system. That is what we call the crystal lattice or space lattice. Okay, now in this space, now we are constructed crystal. So before we construct the crystal, right? So let me draw the very big one. I draw the big box. I show you the box. So we studied through the very sophisticated technique, that is what we call X-ray crystallography. Okay, through that X-ray crystallography. So this crystal, I show you, this is supposed crystal, right? Now this crystal I bring here in this space, that is space what we call space lattice. Now we place in this space this crystal, right? Now in order to understand how the crystals form, now in the simple way, we cut uniformly, we cut it here. We cut half of this portion. We cut this half of the portion, we cut it. Okay, these types of the portion we can find it. Just I draw it similar here, and further we cut it, smaller portion. We cut it further, we cut it smaller and smaller and smaller and smaller portions, and finally we found the very smallest portion. Okay, so that smallest portion we found it. This look like the same as the previous one. Okay, this smallest portion we normally call unit cell. That means unit means one, which we require to construct the very big cell. That is what we call a unit cell. So the model of the unit cell I just show you here. This is supposed to one of the crystals we bring here. This half of the portion, just I cut it. We found like this. Okay. Then after that we cut it half of this, we cut it like this, we cut it half of this, and we found this. And similarly we cut a half of this and we can find look like this, and when we cut off half of this we can find it like this. And finally we could find the smallest portion. That smallest portion I showed the diagram here. This is what we call a unit cell. Understand? Now, so geometrically it looks like a box. Okay, so in this box what we know the dimension. What is the dimension parameter? I write the dimension parameter. Dimensional parameters, right? What are the important dimensional parameters of this unit cell? Show you here. This is the one of the corner, this is the another corner. The distance between these two corners, that is the length of the side. So I mark it here, this is the A. How many sides we have in our box? We have a 3 sides. One side is here, another side is here, and one side is here. So then another corner is here. This distance between these corners, okay, this is the length of the another side. I just write a B. And this is the one of the corner, this is the another corner. So the distance between this corner or distance between this side, so what we just mark it as a C. Now here in our box, just I show you, this is the box. So this part, what we called A's, this is the A's. So this distance between the two corners, so we normally call A's length. Here, how many S length we have in our box? We have a 3 S length. I mean S length, right, in our parameter. So this dimensional parameter we call axial length, or we can say axial distance. Yes, you can note down. This is what also we call X length. So now here, since we have a 3 sides, okay, this axial length, I just mark it here, A, B, and C. And another dimensional parameter is, right? So this is the one of the face, this is the another face. So the distance between the two faces, what we generally, I just write interfacial distance. This interfacial distance we normally call angles, right? So how many interfacial distance we have? One is this, right? And another is this, and the third one is this, right? There are 3 interfacial distance or angle. This 3 interfacial distance we generally call axial angles. These axial angles I mark here alpha, beta, and gamma, right? So I write here alpha, beta, gamma. Now I repeated here. These A, B, C are the axial lengths or axial distance or S lengths, right? And what is axial angles? Axial angles, I write alpha, beta, gamma are the axial angles. So these are the dimensional parameter. How many dimensional parameter we have? There are 2 dimensional parameter. Number 1 is axial length or axial distance or S length. The another dimensional parameter is the axial angles, right? Okay. Now, because of the different dimensional parameters, we can find the different number of the design. We can say the design, different types of the unit cell we can find it. So on the basis of the different dimensional parameters, so how many crystal systems we can find it? There are 7 crystal systems. So this is the crystal system. These crystal systems based on the different dimensional parameter. Different dimensional parameter means when we change this length or this length, some are the same, some are different, and the axial angles, some are 90 degree, some are not 90 degree. When we have a different dimensional parameter, I mean different axial length and axial angles, we found only 7 crystal system. 7 crystal system. What are the 7 crystal systems? Now I start to write. Number 1 is cubic, number 2 is orthorhombic, orthorhombic. Number 3 is tetragonal. Then number 4 is hexagonal. We can write. Number 5 is monoclinic. Then number 6 is rhombohedral. I just write rhombohedral. Then it's also called the trigonal. The 7th crystal system is triclinic. So now these are the 7 crystal systems on the basis of different dimensional parameter. Now here, so what are the difference between them? So let me write them just here. Easier to understand, so you go through the book. So the dimensional parameter of these crystal systems are given in the table, so you can compare it. So from that idea, so I just write in the form of the question here, or the question is distinguish between, let me distinguish between the two. Let me distinguish 1 and 2. 1 and 2, I mean cubic and orthorhombic. So let me say the dimensional parameter of cubic. Let me write a cubic first. So now in the case of the cubic, so the axial length A, B and C, all these 3 sides are equal, right? And what about the axial angle? So in our cubic, the axial angles alpha, beta and gamma, all these 3 angles are equal to the 90 degree. This is for the cubic crystal system. But in the case of the orthorhombic, for the simple difference here, so in our orthorhombic, all these 3 sides are not same, are differing. Here, see, look at this one. This is matches box, as you know. See, this matches box. Suppose this is the one of the crystal system. What is the dimensional parameter? I mean, in the axial length. So this side and this side and this side, all these 3 sides are not same, right? So therefore I write A, B and C are not same, but the angles between the 2 sides, I mean 2 faces, this is also 90 degree, this is also 90 degree, this is also 90 degree. That means this alpha, beta and gamma is equal to 90 degree. What's only different here, in the cubic all these 3 sides are same, but in the case of the orthorhombic all these 3 sides are different. But what is similarity in the cubic and orthorhombic is all these 3 angles are 90 degree, here also 90 degree. This is the difference between the cubic and orthorhombic. Now number 2, let me write number 2, that is hexagonal and the monoclinic. Let me write hexagonal and the monoclinic. What is the difference between the hexagonal? I write monohexagonal. In the case of the hexagonal, right? So what is the axial length? So axial length is A is equal to B. So this length A and B is same, but length of this C is different from these 2, right? Then what about the axial angle? So in our hexagonal, so alpha is equal to beta is equal to 90 degree. So the angle, alpha angle and beta what are 90 degree, but in the case of the gamma, so that is equal to 190 degree. But in the case of the monoclinic, here monoclinic, what is the difference here? So all these 3 sides are not same. And what about the exit angles? Here exit angle alpha is equal to gamma. Let me write the gamma is equal to 90 degree. Then now here, so now here beta, the angle of beta is not is equal to 90 degree. Let me say the 90 degree. No, not a 90 degree. 120 degree. So this is the difference between the hexagonal and the monoclinic. Then come to the trigonal and the triclinic. So here I write number 3, okay, trigonal. You can compare with the books. I think in your book, in the table it's given here. So trigonal, as we know, what is the trigonal? So all these three sides are same. All these three sides are same. But what about the angles? Let me say the angles. Okay, angles, that is alpha is equal to beta. So these two angles are same, but gamma is not equal to 90 degree. So it's slightly different. Now here in the triclinic, in the triclinic, what is the triclinic? What we know, that is A, B and C. So that is triclinic. So what is the triclinic? Here in the all these three sides are different, and this is for triclinic. Okay, triclinic. Okay, all these three are different, and all these angles alpha, beta, gamma are not equal to the 90 degree. So this is for the triclinic, this is for trigonal. And what about the tetragonal? So tetragonal, let me write the tetragonal. Write tetragonal. Tetragonal. Here the tetragonal is here. This length A and B is the same, but C is not the same with the previous two. Then what about the angles alpha, beta and gamma? All the angles are same with 90 degree. So these are the dimension parameters of the this different crystal system. Okay. Now the question is, what we know that in your examination they may asking you distinguish between any one of them. We can compare with might be cubic and hexagonal, orthorhombic with the others. So how we can find it? So this is the simple way we can very easily find out. Now here, based on this, I just write here the simple question which can focus in our competitive examination. I write, see, choose the incorrect dimensional parameters. That dimensional parameter I mentioned here, axial length, I say A, B and C. I write axial angles, it may say alpha, beta and gamma, right? So choose the incorrect dimensional parameter of the following crystal system. So I just write the one of the crystal system in wrong dimensional parameter. I may choose this one, number one, cubic. I mentioned the correct one. A is equal to B is equal to C. Then axial angle alpha beta is equal to gamma is equal to 90 degree. This one is the correct dimensional parameter. Number two, let me choose the orthorhombic. I write A is equal to B is equal to C. So all these three sides are wrong, different. Alpha, beta and gamma is equal to 90 degree. So we can write it. Then number 3, let me choose the hexagonal. Here hexagonal, the correct dimensional parameter is A is equal to B not equal to C. Then what are the alpha, beta is equal to 90 degree, but the gamma is equal to 120 degree. But in the case of the, let me choose any one of them. Suppose I write number 4, I write tetragonal. Here tetragonal. So the dimensional parameters, let me choose one of the parameters. For the parameters, let me choose this one. Simple, this one I write A not equal to B not equal to C, because then the alpha is equal to gamma is equal to 90 degree, but beta is not equal to 120 degree. So this parameter is for the monoclinic, but for the tetragonal, what should be the dimensional parameter? So this A and B should be same, but C is different from the A and B. Alpha, beta and gamma is equal to 90 degree. So the incorrect option is tetragonal. These types of the option, these types of the multiple choice question sometimes asking in your competitive examination. So these types of the knowledge we must have. You go through your book also, and you try to be familiar what is the different dimensional parameter of different crystal system. Do you understand? So you see the book, and this dimensional parameters are given in your book. So keep remember